So in this video, we are going to discuss about properties of unilateral Laplace transform. So which means here the L of x of t formula is Laplace of x of t is 0 to infinity x of t e power minus st dt. So the first property we are going to discuss is linearity. So what we are going to prove is uh, Laplace of a into x of t plus b into we would take x1 of t, x2 of t is equal to a into x1 of s plus b into x2 of s. So this is what we are going to prove. So I am going to substitute this. So the proof is, so what we are going to do is instead of x of t, I am going to substitute entire thing here. So instead of x of t, I am going to substitute this one. So if I substitute in the first equation, okay, so it becomes 0 to infinity. Instead of x of t, I am going to substitute this one, right? So a into x1 of t plus b into x2 of t e power minus t dt, right? So here I can separate it this one, right? So a of a can take it common, x1 of t e power minus t. I can bring this e power minus t inside, right? Plus b into 0 to infinity x2 of t e power minus st dt. Okay? So this I can write it as a into x1 of s plus b into x2 of s, right? So this is a formula, right? So integral of 0 to infinity x1 of t means this becomes x1 of s, because this is nothing but x of s. Okay, capital X of s. So x of x I can write it as x of t, x1 of s I can write it as x1 of t. Okay, so this is about the linearity. So the next property is time shift. So what we are going to prove is so if x of t get shifted by t naught, so you have to get e power minus s t naught x of s. So this is the answer we have to get. So the proof is, so Laplace of x t minus t naught. So you have to substitute in the first equation. Laplace of x of t minus t naught into u of t minus t naught. Okay, so which is equal to, so it is ranging from t naught to infinity x of t minus t naught e power minus st dt. So here the t ranges from t naught to infinity. Okay, so if I consider u is equal to t minus t naught, if I differentiate du with dt with respect to du, I will get du is equal to dt, right? So what is my t? T is equal to u plus t naught. Okay, so if I substitute uh, t is equal to t naught, t is equal to t naught in the equation 1. So this is my first equation, this is my second equation. T is equal to t naught. So substitute 2 in 1. I will get u is equal to 0. If I substitute t is equal to infinity, I will get u is equal to infinity. Okay. So what I am going to do, I am going to change this entire equation. So instead of t naught, if I substitute t is equal to t naught, it goes to u is equal to 0. 0. If it is infinity, it is infinity only. X of t minus t naught, I am going to substitute u, and e power minus s. Instead of t, I am going to substitute u plus t naught. Instead of dt, I am going to substitute d. Okay. So I can take e power minus st naught common, 0 to infinity, x of u e power minus su d. So this is nothing but e power minus st naught x of s. So hence the proof. So next one is frequency shift. So here what we are going to prove is, so here the Laplace of e power minus at x of t is equal to x of s plus a. So this is what I need to prove. So to prove, so to prove, okay, proof, okay. So yeah, Laplace of e power minus at x of t, I can write it as 0 to infinity e power minus at x of t e power minus st dt. Right. So this I can write it as 0 to infinity x of t e power minus uh, s plus a into t dt. Right. So this nth term I can write it as x of s plus a. Right. So this hence it is good. Okay. So next one is scaling. The next one is scaling property. So we are going to prove Laplace of x of a t is equal to 1 divided by a x of s by x by a. So the proof is Laplace of x of a t is equal to 0 to infinity x of a t e power minus st dt. So I'm going to take u is equal to at. So if I differentiate u with respect to dt, I will get this one. So t ranges from 0. If t is equal to 0, u is equal to 0. If t is equal to infinity, substitute in this equation, u is equal to infinity. Okay. So from this equation, I can write t is equal to u by a, right? So I'm going to substitute Laplace of x of a t is equal to 0 to infinity x of, instead of a t I can substitute u e power minus s, instead of t I can substitute u by a, right? Instead of dt I can substitute du by a. So now this becomes 1 by a 0 to infinity x of u e power minus s by a of u du. So this I can write it as 1 by a. The entire term I can write it as x of s by a. Okay. Hence it is so next one is time multiplication. This is another property. Next one is time multiplication. So what we need to prove is Laplace of minus t x of t is equal to d divided by t s ds x of s. Okay. So this or I can write it as Laplace of minus t power n. Okay. X of t is equal to d power m x of s by dx. Okay. So the proof is, so we know that x of s is equal to 0 to infinity x of t e power minus st dt. So if I differentiate this one with ds, okay, I will get 0 to infinity x of t. So I differentiate this term with respect to ds, I will get e power minus st minus t ct, right? So I can write it as 0 to infinity minus t x of t e power minus st t. So this is nothing but Laplace of minus t x of t, right? So this is a proof. So hence it is true. So the next video I have discussed about initial value theorem, then final value theorem, then you have a differentiation, time differentiation, that is transform of derivatives. So this we will discuss in the next video. So here I can also the next one is time convolution. So to prove us the sum, the Laplace of x1 of t and x2 of the convolution of x2 of t is equal to x1 of s, x2 of s. So of t, x2 of t, right? x1 of t, x2 of t, I can write it as 0 to infinity x of x1 of tau, x2 of t minus tau, t tau. Okay. So this is a formula for the convolution. Okay. So what is Laplace of x1 of t convolution x2 of t becomes, so this is equal to 0 to infinity, right? x1 of t convolution of x2 of t e power minus st dt, right? So now you substitute this value. So if you substitute this value, this becomes 0 to infinity x1 of tau, x2 of t minus tau e power minus st dt theta. Okay. So now we are going to take, I'm going to take t is equal to t minus tau. Okay. So if I differentiate dp with respect to dt, I will get dp is equal to dt, right? If I differentiate with respect to tau. Okay. So here the t is ranging from 0 to infinity, right? T is ranging from 0 to infinity. So if I substitute here, the p becomes minus tau and t becomes infinity. Okay. So now I'm going to substitute in this equation. So this becomes 0 to infinity. And have another equation, right? Here it is 0 to infinity. For 0 to infinity, x1 of tau, x2 of t, right? C then e power minus s p plus tau dp theta. Okay. So this I can write as 0 to infinity x1 of tau e power minus s tau d tau into 0 to infinity x2 of p e power minus sp d. So now the second it has x of x1 of s, x2 of s. So hence the proof.